time to get into our unit of transformations. And I know we've done transformations before in the past couple years ago. You dealt with the general concept of, reflections and rotations and translations. And we've even touched a little bit on dilations before. But now we're going to get a little more in depth and we're going to see how it affects it on the coordinate plane. So first thing, let's talk about reflections. Okay, the keys here, pretty wordy, but we're referring to a reflection in a line. Okay, we're going to have a line that's going to be reflected from that line, on that line. So first things first, if the point is on the line and it's reflected, the image and the pre-image are the same point. And I got an example here. So if you take a look, we're reflecting the point A, and it's being reflected on the line K, which is right here. Well, if you notice, if I reflect it on that line, well, it's already on the line, so it just stays the exact same point. So our new point, our new image, we call A prime. That's the A with the apostrophe. We call that apostrophe. We call it prime. So that's the new image. So A was the pre-image, and A prime is the new image. And if it's reflected on that line, it's just the exact same point. Okay, well, let's take a look. Well, what if the point wasn't on the line? But I'm going to reflect it on the line. Okay, so the point does not lie on the line. And if we take a look, so now I have A. So here's my pre-image. When it gets reflected by the perpendicular bisector in the exact same distance. Let's think about that. Well, it's got to go perpendicular to the line that it's being reflected on. And then it's the exact same distance on the other side. And we call that A prime. So basically you're just going the exact same distance on the exact opposite side of the line. So same distance, got to make it perpendicular, right? So if I reflected A here, I wouldn't reflect A prime up here because that's not the exact opposite side. This is where A prime would be. Okay, so it's got to be the exact opposite side and the exact same distance. And we'll take a look how that works on the coordinate plane. But first, let's just look at it in general. So if I have this image and I want to reflect it on line P, what I do is I want to work by each point. So look at each point individually. So first of all, I'm going to go to W. I'm going to take a look. I'm going to use a ruler here. I'm going to figure out how far W is away. And I'm just going to guesstimate on the perpendicularness. Well, it's about a centimeter. So I'm thinking, if I took a look, oh, I want my centimeters. So W is about a centimeter away. So I'm going to go the exact opposite direction, perpendicular, about a centimeter. So I'm going to take my ruler. I'm going to measure about a centimeter, which in this case would be about right here. So I put my new dot the same distance away, right? And it should be perpendicular to that line, and we call that W prime. That's my new image to W prime. And I would do that for every single point here. So if I'm going to quickly run through X. It's about 2 centimeters, so I'm going to go 2 centimeters. It's about right there. So I'm going to call that X prime. And then Y is about, might have to adjust this just a little bit to get it perpendicular. Y is about almost 3. So keep the perpendicular. I'm going to measure about 3. Okay, so Y is about out here. Doesn't have to be perfect, okay, but the best you can. And that's Y prime. And then if I reflected Z, make it about perpendicular, and Z is a little over 1.5. So a little over 1.5. About right there. So that would be Z prime. So there we go, Z prime. And then I'm going to connect all my dots to make it look the same. It should be the exact same size. So there we go. I reflected it over line P, right? So just the perpendicular from the point and the exact same distance on the other side of the line. Okay, this is actually used in billiards. So if I think about this, it says Tadeo is playing billiards. He wants to strike the 8-ball with the cue ball. So the 8-ball bounces off the rail and rolls into the indicated pocket, shown by that yellow arrow. The 8-ball moves with no spin. Draw a diagram showing the exact point P along the right rail where the 8-ball should hit after being struck by the cue ball. So obviously, in pool, you can put some different spin on it. That might affect it. But if I hit it straight on, what am I looking for? Well, let's take a look. Let's think about where the middle of this pocket is and the distance to where it's going to hit the wall. Well, here's the wall. So it's it's about 3.6 centimeters. So basically, I want to measure 3.6 centimeters on the opposite side of that wall and perpendicular to the hole. So here's the hole. So perpendicular is coming right along here. Make it perpendicular and about 3.6. So right at that blue dot. So this is really my line of reflection right here. And I'm reflecting this point where that hole's at off that line. So that should help me find my angle that I want to hit that cue ball. I could use the ruler to help me out here. Be a good idea. So I want to match that up about just like that. So here's the line that I want to take. So there we go. If I hit that cue ball right at this spot on the wall, it should reflect perfectly into the pocket. Okay, and that's how pool players think of that. They think about the distance from the hole to the opposite side of the wall, and that's how they figure out their angle. Obviously, it takes a lot of playing as well, and then it just becomes kind of more natural, but mathematically, that's how it would work. On the coordinate plane, this is where we're going to get to mostly, and it's nice and easy once you find your rule. Okay, so kind of wordy, but let's just take a look. Let's look at this left one here. To reflect it on the x-axis, okay? So if I'm going to reflect on the x-axis, that means I have a point up top, and I'm going to reflect it across the x-axis. Let's look at this point A right here at 4, 1. If I'm going to reflect it on the x-axis, all I have to do is this little rule. The x doesn't change, right? It's still the same distance in the x direction. It's over 4 when it gets reflected. So the x does not change. So if this is my original point, and I'm going to reflect it, x stays the same. Actually, we'll use green here. X would stay the same, but the y is on the opposite side of the x-axis. So if the y was 1, its reflected image would be -1. So it's just the opposite of y. So when you reflect on the x-axis, the only thing that changes is the y value on the coordinate. It just becomes the opposite. And the same thing works vice versa for the reflecting on the y-axis. If I would reflect on the y-axis, and if I'm going to reflect this point A, x, y, in this case it was 2, 3, it becomes, well, what happens? The y is still the same, right? It's still up 3, but now if I look, it's on the opposite side of the y-axis. So the x would change for the y-axis. And so the new image would be -2, 3. That's all that happens. Let's try an example here. So it says graph the figure and its image under the given reflection. So let's graph the figure first, A, B, C, D. So I got A at 1, 1, B at 3, 2, C at 4, -1, and D at 2, -3. Oh, I want to go down 3 then, don't I? 2, -3. A, B, C, D. Okay, so there's my quadrilateral. And then I want to reflect it on the x-axis. So what I like to do is I like to write my points off to the side just so I can see them. And just what we talked about, how do you reflect for the y-axis? What changes? Or x-axis, I'm sorry. So reflect on the x-axis, all that changes is the y, right? We just changed the y. The x value stays the same, but it's on the other side of the x-axis, so the y changes. So A prime would be at, well, the x stays the same. All that changes is the sign on the y. So for B prime, 3 stays the same. Now it becomes a -2. For C prime, 4 stays the same. This becomes a +1. For D prime, 2 stays the same. -3 becomes a +3. And then I go ahead and graph. So they should be on the exact opposite side of the x-axis. So if I look at A, right here, right? The exact opposite side would be right here, and that's my point, right? 1, -1. So that we call a prime. And then I do that to each one. So B is at 3, -2 now, or B prime. C prime is at 4, 1. So 4, 1. Should be the exact opposite side of the x-axis, and D is at 2, 3. Or D prime is at 2, 3. And then I connect those, and it should almost look that the x-axis is being a mirror, right? It just mirrors the image. Okay, so some points are on each side of the x-axis. That makes it one a little bit goofier, but if you just follow your rule, right, reflection on the x-axis, all that changes is the y, the sign on the y. Okay, we could actually reflect it something besides just the x-axis or the y-axis. This one we might have to think about a little bit. Let's go ahead and graph our quadrilateral, JKLM. So J's at 2, 3. K's at 3, 2. L is at 2, -1. And M is at 0, 1. So there's my quadrilateral. And it says, graph JKLM to that and its image in the given line. So this is where the reflection is occurring. Well, first of all, I got to know how to graph that. And if remember, all we go to is -2 on the y-axis. So where's -2 at? It's right here. And what kind of line would that make? Remember, it's a horizontal line because it doesn't matter what the x value is, but y has to be -2. So all these points would work if I graph that, right? 0, -2, 2, -2. That's how we think about that. Just go to -2 on the y-axis and draw on your line. Should be horizontal. So I'm going to reflect it over that line. Well, now instead of looking at the exact points, what I like to do is anytime I get this, I just like to count the units. That's what helps me out. So for example, if I'm looking at L, how far is L away from that line of reflection? It is 1 unit away. So I go 1 unit away in the opposite direction. There you go, L prime. Well, how about M? How far is that away? 1, 2, 3. So I go 1, 2, 3 in the opposite direction. There's M prime. And I do that for each one. So J is 1, 2, 3, 4, 5 from the line of reflection. So 1, 2, 3, 4, 5. So there's J prime. And lastly, K is 1, 2, 3, 4. So I got to go 1, 2, 3, 4 for K prime in the opposite direction. Okay, kind of hard to see my points, but J, K, L, M. There we go. So just count the units that it is away from your line of reflection. That makes it much easier. And lastly, the other thing we could reflect it is in the line y equals x. That line y equals x, basically whatever x is, that's what y is. So if I look at my line, which is right here, when y is 1, x is 1. When x is 2, y is 2. So 1, 1, 2, 2, 3, 3, 4, 4. That's why it makes that diagonal line right through the origin. And all that happens is, if I take a look at an example, if I reflect it in that line for B, -1, 4, all that happens is that the coordinates just switch spots. So the 4 becomes the x-axis, and the -1 becomes the y-axis for B prime. That's all that happens. And you can see that right here. So xy becomes yx. So all you do is just switch the spots of the coordinates. So let's try one of those quickly. Show you how easy it is. So we'll graph first of all. So we got A at 1, 1, B at 3, 2, C at 4, -1, and D at 2, -3. There's my quadrilateral, and we're going to reflect on the line y equals x. So let's do A quickly. So 1, 1 becomes, well, that one's kind of nice. They switch spots, so it's still 1, 1. Let's do B. That may help see a little better. So 3, 2. So that means B prime, the new point. Well, for the y equals x, all that happens is the x and the y just switch spots. So that becomes 2, 3. And so quickly, C prime would be -1, 4, switches spots, and D prime would be -3, 2. And then we just graph all those. So 1, 1 for A prime, 2, 3 for B prime, and then we got -1, 4 for C prime, and -3, 2 for D prime. And let's just graph this in. Oh, Didn't get that one quite very good. And if I drew in my y equals x line, that looks pretty good, right? Should reflect right on that line. There we go. So just follow those couple rules, and you're good to go.